Our last operations, adding and subtracting rational expressions. Again, similar process as with numbers, right? So we are going to eventually, once we get to a common denominator, we're just going to add or subtract numerators only, yeah? So it doesn't seem too hard, right? But getting to that common denominator is the tricky piece, right? It's a little bit of an art, but let's review it with numbers first, and then we'll worry about adding variables into the mix. So if we have 4/3 minus 2/7, right? We cannot just say, it's 2 over what, 4, -4. We don't do that. No, 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 no. So we need to make sure we have same size denominators, and so we need to search for a common denominator between 3 and 7. And so many times it could be as easy as just multiplying the two and say, okay, well, the common denominator is 3 times 7, which is 21. And sometimes that works. Sometimes, you could find something smaller. Whatever floats your boat. But this multiplying the denominators together will always give you a common denominator. Perhaps not the least common denominator, but that's okay. You just have more simplification to do. Once you find the common denominator, you need to multiply each fraction, numerator and denominator, by the missing component of the denominator. So for example, this first fraction is missing 7. Okay, in the denominator. So if I introduce it in the denominator, I have to introduce it in the numerator. This second fraction is missing a 3, so that has to be introduced in the numerator as well. Okay, and so then when I go forward with this, I have to perform the operation. So 28 over 21 minus 6 over 21. And now that I have same size pieces here, I can say, okay, perform just a subtraction between the numerators, so that'd be 22 in the numerator over the same size denominator, 21. And if I need to simplify, I can, but I don't think I can. No, I can't. Okay, so there's no common factors, so I'm just going to leave it like that. All right. So again, not a terribly long process. It is this the sticking point is going to be the common denominator, and then also doing the multiplication to each fraction or each rational expression. Okay, so let's just try it. I'm going to do a couple, and then you get to do the rest and see the solution. Okay, so first one, oh, those actually have common denominators, right? So then this is just illustrating, okay, when they have the same denominator, just combine everything together. So it'd be 9x plus 14 plus x squared, and you'd be done. But remember, there's that simplification piece, yeah? So let's put this at the front, and then this, I think, factors x plus 7, and then this would factor as x plus 7, x plus 2. You're welcome to use whatever method you need to get that to factor, and then these factors end up reducing, and I'm just left with x plus 2. Oh, that's nice. Okay, and I was able to factor in the denominator because the x plus 7 was chunked. I treated that as all one chunk. Okay. Okay, up next. Okay, this is the one that I'm going to do fully, and then I'm going to get you started in the next one and leave you to do it on your own. Well, and see the answer. Okay. So here, I think we have to find a common denominator first, and I can't just say, because there's multiple things here, it isn't just, x and then I need to add in 3 or whatever or subtract 2. No, I can't do that. It's actually like this is one whole number, right? And so for the common denominator, I need to multiply those numbers together. Okay? So then that means I need to multiply this first expression, numerator denominator, by x plus 3. And the second expression by x minus 2 to numerator and denominator. Okay, and when I do that, I get 2 parentheses x plus 3 over x plus 3. Oh my gosh, x plus 3, x minus 2, plus 5 times x minus 2 over x plus 3, x minus 2. And so then I would get, and let's see, I'd get 2x plus 6, I can distribute here, and then plus 5x minus 10 all over x plus 3, x minus 2, and then I can just simplify here, so I get 7x minus 4. Yep, 7x minus 4. Yep, over x plus 3, x minus 2. Okay, and the denominator, if you wish to FOIL it out, you're welcome to. I'm not going to. All right. All right. Last example, perhaps the most challenging, and I know you can do it. Here we have a fraction, right? So a fraction with the variables in it, we're going to be fine. So it's a rational expression. And my first hint to do this operation, right? You can multiply, you know, these two things together, but maybe we can get to a better common denominator by looking at its factored form. So this first one factors as x minus 2, x plus 2. And the second one factors as x minus 2, x plus 1. Okay, what is the common denominator here? If you want to put them all four together, that works, but maybe there's a shorter one. Okay, so try it on your own, pause the video, resume when you're ready to see the solution. And here's my solution. Okay, oh, I forgot to box it. Okay, so the common denominator that I used, it was not all 4 pieces smushed together because there was a repeating x minus 2. So x minus 2 is already a factor between the two. So that one went into a single factor in my common denominator. And then I added in the x plus 2 and x plus 1. The advantage of this is that you have smaller things to work with and there's less simplifying that you need to do. Okay, down the road. Okay, otherwise, if you smush them all together, it will work. You just have to do a little bit more factoring, a little bit more simplification. Okay, and so same principles apply, but you can see the rest of my work here. One thing I just want to note is that when you distribute the 3 here, the negative goes with it. So that's why we get a negative 6 here as opposed to a positive 6. All right, otherwise the same works here. In summary, right, the process of adding and subtracting rational expressions, same as fractions, right? The big sticking point can be finding the common denominator. Okay, so I always recommend factoring first. And here I didn't have to worry about canceling too much. Oh, I should maybe mention here that x can't be negative 7 since I canceled, but you're welcome to note the other undefined values for each of these. But otherwise, yeah, we do the same process as we do with fractions, just making sure that this time when we're searching for our common denominator, we're being as smart as we can by factoring.